Hello and welcome. I am Cesar, VP of Engineering at StackGen, and today I'm happy to talk to you about transforming DevOps and managing Modular Infrastructure. I spent years battling the chaos of infrastructure management before StackGen at the financial industry, and today I'm here to share some of those hard-won secrets of making DevOps life just a little bit less painful. Let's talk about some of those daily headaches that we face with manual configurations, inconsistent deployments, and infrastructure drift, and how to overcome them. And before we get started, let me share with you what I think about and what comes to my mind when I hear the word drift. So, first thing that comes to my mind is and I'll share a story here. Every now and then at night, I go to my kids' playroom. I put all the toys away. I put things in the shelves, things in the closet. But the very next day, once they get into that playroom, I experience drift. I and it's a little bit painful. But let's talk a little bit about some of the lessons that I've learned throughout the years on how to make that drift and that chaos that sometimes we experience in our daily lives as DevOps engineers a little bit less painful. All right. So um, let's talk about some of the challenges in modern DevOps, and I'll talk within the context of StackGen because we designed StackGen to make infrastructure management seamless for for me, for DevOps teams by eliminating some of those manual processes and trying to automate as much as possible. So first thing is infrastructure complexity, and this is the pain that a lot of us feel when we manage things like multiple cloud environments, sometimes across different cloud providers. For example, here at StackGen, we have an environment in AWS, one in Azure, one in GCP. Um, we have microservices, Kubernetes, and all of that adds layers of complexity, which sometimes can make troubleshooting a little bit tricky and scaling a little bit difficult. Um, Also, sometimes we have slow and error-prone deployments in traditional CI/CD pipelines. There's manual intervention, security gates, operational gates, architectural gates, which cause delays and may introduce human errors, you know. And I'm not gonna blame you if you implemented a manual gate within your CI/CD process. I've done it myself um, in my prior life as a security architect, and and ideally we want to automate as much of that as possible as we can, just for the sake of all the stakeholders. The next thing is the misalignment between dev and operational teams. So yeah, the developers want to go fast. They want to meet their business objectives. They're getting a lot of pressure from the business to deliver as quickly as possible. But we as ops people, we want to make sure that there's stability in the environment. We know that we're going to be the first one to get called and paged if something goes wrong. So sometimes we're a little bit hesitant, and there's some friction, and which can cause delays, inefficiencies, and duplicated efforts. All right, so within StackGen, we designed the system to make infrastructure management seamless by eliminating a lot of those manual processes, and we enable automation at scale. We want to empower engineers to focus on innovation rather than what I like to call a technical term called the boring stuff. So to me, the boring stuff is things like maintenance of old Terraform templates, maintenance of Helm charts, responding to tickets and escalations. We want to eliminate that as much as possible and accelerate deployments and ensure that you can focus on the reliability of your environment um, and the important stuff. So the special sauce behind our product at StackGen are these critical benefits. First is infrastructure from code. So for us, code can mean multiple things. So it can mean source code, like a Java application, a Python application, Golang, C Sharp, or it can mean your configuration files or things like your existing Terraform state file. So we want to eliminate the cognitive overload and manual scripting. And what IFC allows us to do is to ingest either your existing environment through state file or ingest what the developers of a particular software system application need and what they codified by inferring the dependencies that they injected within their application source code itself. The next thing is visual deployment topology. So I know that sometimes we dread UIs and we want to go to the CLI, but have you ever been in a meeting with a development team or an architecture team and they drew up the most beautiful architectural diagram or the most crappy architectural diagram, and it didn't really reflect the reality of what you were observing in the actual environment? So I've been there too. So this is what we want to eliminate with our visual deployment topology view is we want to make sure that teams have a clear interactive way of viewing the reality of their cloud environment. And it makes it easy to debug, it makes it easy to optimize, to scale deployments, it makes it easy to communicate with stakeholders because you're seeing a picture of what the actual environment and its configuration look like. So we have more visibility into our infrastructure components and dependencies, and it can really optimize communications, troubleshooting, and optimization. Everything within this visual topology is backed by the next bullet, which is declarative and modular infrastructure. So our idea here is that within the infrastructure that topology that we design, we're always going to have declarative templates that are going to be backing that topology. And these could be things like Terraform and Helm chart that our system and StackGen supports out of the box, or it can be your own Terraform modules that have been hardened to sweat blood and tears through production incidents and that you know and love. You can bring that in and it will help you ensure consistency across your development, staging, and production environments. It will help you prevent configuration drift and it will help you minimize errors. So we want to make sure that your infrastructure management is as simple as possible through using reusable and composable modules. Next is all these tools help prevent and fill the void between what our dev and operational team experience. So we try to accelerate the SDLC and try to reduce as much as possible some of the redundant and duplicate efforts across these teams. So let's take a moment to break down infrastructure from code. So if you're familiar with IAC infrastructure as code, you know it requires writing things like YAML, Terraform, scripts to define your cloud environment. With IFC, we take this to the next level by automatically generating infrastructure configurations based on your application code. So there's no manual scripting for your developers, folks that always complain when you give them the task of writing Terraform. There's no more cognitive overload. It's just seamless infrastructure that aligns directly with your software. So why is this a game changer for DevOps teams? It eliminates human errors and inconsistencies because now we make sure that the infrastructure is always defined from the application needs. It also drastically accelerates deployment time since your infrastructure is provisioned dynamically it reduces bottlenecks, and it simplifies rollback. Um, and I'll give you an anecdote. After the next bullet. So IFC enhances collaboration, so developers can focus on coding while operation teams can gain better visibility and control over deployments. So here's the anecdote. One of our first customers, when we were developing this IFC concept and feature, one of the things that we found was we were trying to test how does the um, Terraform code that we generate through StackGen compared to their existing Terraform code for a particular application in this customer's environment. And so we ran StackGen, we ran the tool, it kind of worked. This is the first time that we're running it with a customer environment. It kind of worked. But the most surprising thing were the things that it didn't find. So in the Terraform that the customer already had, there were resources like S3 buckets that the infrastructure as code was defining. They had Terraform templates defining this, but um, but with StackGen, when we scanned the application, we didn't see those resources. So yeah, we thought it kind of worked. It kind of worked, but I'm not sure because I have a S3 bucket defined in Terraform and I don't see StackGen generating that. So we dug deeper into the code to check what's happening. And then that's when we realized that there were a bunch of resources that they had provisioned, but they never took the time to decommission those resources once they're no longer needed. And this had happened to me many times. Where in the day zero of your development lifecycle, you may think that you need access to certain resources. You may think that you are gonna do X, but then you end up doing Y. And this is the problem with manual security gates. Usually you just go through that gate with your original plan, X, but once you switch to Y, you don't go back to that manual security gate to refine the plan from an operational and security perspective. So that's the benefit of IFC. Your infrastructure is always consistent with the reality of your code. All right, so let's talk about designing and managing and troubleshooting with a visual topology. So imagine being able to see your entire infrastructure in a clear, interactive way. There's no more guessing what's running where, no more digging through endless YAML files. You get called up to for a production incident. You call the development team. There's no more guessing because a lot of these development teams may not know what's there. They may have inherited the code. They just did a few changes. The people that originally wrote the system are no longer employed by your company. So you're basically screwed. But and that's the benefit of having a visual deployment topology. And that's what it enables. Instead of just abstract configuration hidden in code, you get a live, real representation of your cloud environment, of what your system looks like. You can drag and drop resources, see directly how code will impact your infrastructure, and eliminate a lot of those manual provisioning, a lot of those tedious configuration within YAML. And with StackGen's visual topology deployment, your team can quickly identify those bottlenecks. You can troubleshoot issues. You can optimize deployment. You can outsource some of these tasks to your development teams that may not have the knowledge on how to operate at the code level. And the really cool thing is that you have a single pane of glass that connects infrastructure components and application dependencies and cloud resources. So it makes it really easy to debug, to scale, and to give you one of the most important things, which is faster decision making. So yeah, definitely it can reduce your downtime, and it's very intuitive and a very easy way to manage your cloud applications. So one of the biggest challenges in DevOps today is managing infrastructure at scale while you ensure that your environments are consistent. And that's where declarative infrastructure and modular deployments come in. So instead of relying on procedural scripts, things like spreadsheets, things like Python code, um, where every change you have to explicitly define it on a step-by-step. Declarative infrastructure allows you to state the desired outcome, and the system ensures it happens automatically. So these are things like Terraform, Helm charts, CloudFormation, Azure, RM. Also with StackGen, infrastructure configurations are not just declarative, but they're also modular. What we mean by that is that instead of managing a monolithic, tangled web of configuration, you can start breaking everything down into reusable, composable modules, whether it's a networking stack, Kubernetes cluster, a database setup, having these modules that can be easily reused. It can 10x the understanding that you have of your system, and it can really reduce some of the redundancies and human errors that we can experience in a very large scale environment. So you get faster deployments, you get reduced complexity, you get better reliability, especially as you harden those modules over time. And you can roll out those infrastructure changes with confidence because your modules have been battle tested, and you'll know that your environments are going to remain consistent from development all the way into the production. And when something needs to scale, you don't have to reinvent the wheel. You just reuse what's already been working. So StackGen's approach to declarative and modular infrastructure helps you move faster, safer, and smarter, and allows you to focus on the things that deliver value instead of firefighting all the time. All right. So developers want to move fast. They want to ship new features. They typically have a lot of pressure from the business to iterate quickly and focus in on writing their code. While operational teams, on the other hand, they're responsible for maintaining the stability, the security, the compliance, the governance of the system. And typically, we're the best for the ones that are kind of receive the first call and the blame when things go wrong. So this often slow things down to avoid risks. So this tension can lead to bottlenecks, miscommunications, inefficiency, and StackGen bridges this gap by enabling a shared understanding of infrastructure. So with infrastructure from code, developers don't have to worry about writing infrastructure scripts. StackGen will provision automatically your cloud resources based on your application code. And meanwhile, operational teams get the full visibility and control through the visual deployment topology and declarative modular infrastructure, making sure that you're always in compliance, that you're consistent, and that you are at scale. So we want to help you move faster without sacrificing on that security and stability. So we'll trying to bring true DevOps collaboration to life. And I'll show you what this means in a demo in a few minutes. So let's talk about a case study here. So one of our customers had developed their whole environment in a particular region. They were using a combination of CloudFormation templates and manual provisioning via the AWS console. And even when they use CloudFormation, they use that for the beginning of their project. They wrote a nice CloudFormation template, but then over time, things started to drift. They started doing manual changes. And now the challenge was that the business had some regulatory requirements based on privacy that required them to be in a particular region for a particular set of customers. So they had to provision an additional environment in an additional region. And the timeline for that was, as you can imagine, it was months because now they had to copy paste what they've done for over years in one particular region, now into a new region. So what we did here is with StackGen, we were able to automatically scan their current state um, region. Um, we From that scan, we created a state file that when then we inserted into StackGen. StackGen then visualized the deployment topology, their architecture, the infrastructure architecture of their system. Um, that helped them optimize some of the bad decisions that they made. They look at what things were looking like. They variabilize some of the parameters within that topology. And at the end, they had some reusable Terraform modules that they used to provision the control plane of their new environment in the new region. So we definitely help them reduce some of the manual intervention because I don't know how would they have done this quickly without StackGen. We help them accelerate some of those deployment cycles. Um, and then everyone was in the same page. So you had real-time feedback. Everyone was on the same page because we had a nice topology of what the system was looking like. The dev teams and the ops team could collaborate easily and quickly based on that visual diagram, which make the end system more reliable, which is really good. At the end of the day, DevOps is all about efficiency, delivering software faster with fewer errors and at scale. But the reality is that managing infrastructure often slow teams down. Manually writing configurations, debugging, failed deployments, and ensuring consistency across environments take up valuable time that could be spent on better things like innovation. So with StackGen, you can move fast without breaking things, ensuring that your cloud environment is optimized, compliant, and ready to scale. So now let's see what StackGen looks like in action with a quick demo. I'm gonna log in with my Google account, and the first thing I want to show you is how can StackGen import and generate your infrastructure from your source code. For this demo, I'm going to use one of our StackGen demo repositories. It's called Retroboard, and Retroboard is a Python-based serverless application. It is available in our GitHub at stackgen-demos. And it has three functions. One is the API function, the other one is the send email function, and lastly, a function to send Slack alerts. So I'm going to go ahead and click proceed. And if you see, as you can see here, AWS Lambda is selected by default. We can see some of the policies that have been enforced. These policies are a little bit different than traditional policies because this instead of being reactive policies, checking the compliance of your existing state, these are proactive policies. When you enforce policies at the inception of your infrastructure as code generated, StackGen makes sure that whatever policy you pick is in compliance by default. So we have different frameworks that are supported here. We also have policy domains that you can pick and choose depending on your requirements. So I'll click proceed here and I'll name this Retroboard demo. We'll have a demo label as well. All right. So I'll hit create. And once I hit create, our system goes ahead and clones the repository and performs static code analysis on that repository, extracting all the traits, all the API calls, and the configuration of the application that allows us to determine what would its infrastructure architecture looks like And then it generates this architectural diagram showing us the resources that the application is exposed to and how does it relate relationships between the resources. One thing that it pops up here on the right is things that we cannot determine from the application source code. These are things like values for environment variables, SNS topic name in this example. So names, those are typically things that we don't see on source code. So I'll go ahead and convert these to TF bars and give a values for some of these environment variables that these Lambda functions require. And this is your canvas now. This is your infrastructure architecture and the what we observe from the source code itself. There once you have this, there's multiple things that you can do. If there's resources that for some reason you don't have in your source code that you want to drag and drop, you can click here on the left-hand side, click on add new resource, drag and drop it into the canvas, configure that resource as you see fit. While you're doing this, if you accidentally violate a policy and save it, our system will automatically detect that. You'll get a warning here. It'll show you what is the policy that is being violated. Why are you violating that policy? How to fix it? If you click on that violation, it'll point you to the exact place where you can make that fix. And once you save it, you are good to go. Wait, what did I do? There we go. Everything that you see in this canvas is backed by modular and compliant infrastructure as code. We output Terraform for the cloud provider's control plane, Helm charts for Kubernetes-based deployments. And then there's different types of connections between the resources here that define the relationships. One is the dependencies, or so if you can see here, this Lambda function is connected with an API role. And if we click on this icon, we can see that the ARN of that role is being connected to the input of the role in the Lambda function. So this is translates here to, where is it? Oh, permissions. This role reference. And then if you see here, the API function is talking to an SQSQ. If we click on the icon here, we can see the IAM policy that is being generated. If we scroll down here, we can see besides the KMS access that we're giving for encryption, we're also giving it SQS send message. And the reason we are giving this permission is because we observed within the source code of the application of the API function that it was performing send messages API calls. And that's the only API call that we observe. So we give it least privilege permissions by default. The other type of connection here are triggers. So if you click here on this trigger, you can see this SNS topic is going to trigger this Lambda function for sending Slack alerts. Once you're good with this architecture, this topology diagram, you can always export your generated ISC. You can download it if you want to bundle it locally and play with it. You can push it to your GitHub repositories, GitLab, Bitbucket. You can also use our CLI to integrate within your CI/CD pipelines. We also have a GitHub action so you can leverage if you're in GitHub. The next thing I wanted to show you is a modernization use case. So let's say that you already either have Terraform in place that was created a long time ago, or even if you have a cloud account where you created resources via ClickUps, we can ingest those as well. So I am gonna go here and click from deployment files, and I'm gonna give it one of my state files that I have here for demo purposes from an Azure environment. Once I click proceed, I'll select Azure as my source, and I'll pick all of my policies here by default, and I'll name it Azure Modern, and I'll create the app stack. And here you can see we're doing the same thing. We're inferring what are the resources, what are the connections between those resources to give you an architectural diagram. And regardless if this is coming from your cloud directly using our cloud to code tool to scan your existing cloud environment, or if you have old state files that you want to bring to in compliance with the best practices, the output of StackGen is always modularized infrastructure as code that follows the best practices and that can give you very, very good confidence of what you're running in your cloud and how you're running it without really having to get into deeps of how Terraform itself work, how IC itself works. And having this canvas, it's really useful for having conversations between different teams, from your development team to your operation team, from your security team, having a clear picture of what's running in your environment, how is it running, how does it look like, and dependencies between resources from an architectural perspective can really accelerate some of those bottlenecks that we have in manual processes where we have to have meetings and gates to understand what's really happening. Here the DevOps and governance team can focus on enforcing policies, and the developers or consumers of your cloud infrastructure can just focus on building and provisioning these building blocks. Everything that you see here within StackGen can be customizable. You can bring your own policies. You can bring your own modules if you have Terraform modules that have been hardened that you know and love and has sweated over incidents over time. You can bring those in, and we just want to make it as easy as possible to adopt cloud in general. So thank you so much for your time today. You can scan the QR code here to schedule a meeting, or you can visit stackgen.com to learn more. And I look forward to chatting with you and meeting with you in the future.